Welcome to this session. So far we have discussed about the basic design expertise. With the discussions that we so far had, given a problem, you can develop a reasonable design solution. But then how to come up with a better design, those aspects we will focus now. We will first discuss about some principles which we must be aware to avoid some bad mistakes which make the code very bad, and we should consciously try to make use of these principles wherever possible. And we will see that the design patterns which we discuss just couple of sessions away, after few sessions, we will see that the design patterns, they embody all these principles, these good principles. And if we know these principles, we will be able to understand why the design patterns do certain things in some way. For example, we might see that the design patterns make use of the interface classes and the abstract classes very profusely. And if we know the design pattern, the design principles, we will understand that why they did like that. Otherwise, we might consider the design patterns to be unnecessarily complex. To get a good understanding of the design patterns, we must first discuss the basic principles behind good design, and that we will do in next couple of sessions. Let us start discussing about the object oriented design principles. A bad design, the system becomes rigid, everything is tangled, you change one thing, the other thing you see that it has to change. The system becomes fragile, you are trying to fix one feature, but as you fix that, the other feature have stopped working. The system is immobile, becomes hard to reuse anything from the solution that is developed, because the code is so interdependent that you cannot just take out one part and reuse at other places, you have to take everything. The system is viscous, that is hard to understand, very complex, it is more complex than what it should be. Lot of repetition, but then it is hard to eliminate them. And this part of the discussion is based on the work of Robert Martin, his book on object oriented design. And the main culprit here is the dependencies, and all these symptoms of bad design and bad code is the dependencies. The dependencies are very high in a bad design. In a good design, we try to reduce the dependencies. The dependencies arise due to a number of reasons. We will identify what are the reasons, and then we will discuss how to reduce these dependencies. The principles that we discuss, they are largely how to reduce these dependencies. If the dependencies are there, then all the problems come, like design unmaintainable, you modify a small part, but other parts stop working, it is difficult to reuse, difficult to understand, and there are too many bugs, it's hard to fix the bugs and so on. The common causes of dependency, first is tight coupling. In our principles that we will discuss, we will identify what gives rise to the tight coupling. Overuse of inheritance. Inheritance is a very important feature in object orientation, is supposed to help in reducing the effort, make the code elegant, but then many times the developers overuse. We will see the situations where the overuse occurs and that make the design bad. Inheritance, we know that we extend functionality by subclassing, but then this is a powerful tool, but once we have this tool in our hand, everything looks like a nail and we try to apply the tool. Like we have a hammer in our hand and then everything appears like a nail. Every fix that we want to do or every development, we want to use the hammer, and that will create real problem. We will identify that what are the problems with overuse of inheritance and how to avoid them. Creating objects by explicitly specifying the class, we say new and some class. It looks very natural to us in the initial coding that we have to use the new method on the specific class and get the object, but we will see that it really makes it increases the coupling. Dependence on specific operation of concrete classes, this is another problem, and dependence on specific platforms. Now, we will start discussing about the principles and we will see that we will try to tackle these problems. The problems are tackled through 5 important principles as mentioned in Robert Martin's book. The first is SRP or the single responsibility principle, OCP or the open close principle, LSP the Liskov substitution principle, ISP the interface segregation principle, and DIP the dependency inversion principle. These are 5 good principles, very important each principle to reduce the complexity in the design and reduce the bad things in the design, and we will see that the design patterns we discuss are compliant to all these principles. If we look at the acronym of this SOLID, these are the 5 principles, and popularly these 5 principles are called as the solid principles. When you are reading a literature, a paper, you might come across these principles. For example, they may mention that violates the Liskov substitution principle or the interface segregation principle and so on, and we will try to understand these principles, and not only this will help us develop better code, help us in appreciating the design pattern solutions, but also later you will have ample opportunity to come across these principles as you design problems or part of a development team. The first principle is based on an article by Robert Martin, which is called as OCP or the open closed principles. The statement of this principle is that classes should be open for extension but closed for modification. The main idea here is that once we have developed a class, we have tested it, found it working without bug, then we should not modify it, because if we modify it, not only that there can be bugs, but also the other classes which are making use of the services of this class will be impacted. Once we have a class which is working, if we need additional features, we should only extend a class which has been developed and tested. A developed and tested classes should be closed for modification, but open for extension. If we need more data members and operations, we can add them through inheritance. That stands for the open for extension, and closed is that we should not modify a working code, working class. The open close principle, the open closed principle is the principle that whenever we want to add any new functionality or modified functionality, we should only extend the existing class. If the class is already working and tested, there are several classes which invoke its service. If we modify this, not only there are chances of bug in a already tested code, but also several other classes will be impacted. They may have unexpected bug because of the changes that we make. So, a working class we should not change, that is closed for change once it is developed and tested, but it should be open for extension. So, that is the open closed principle. Once we have a class which is working, tested, we should put under configuration control and will allow only read only access, or we may declare final etcetera. So, that no modification can be done. There are various ways we can have the closed implemented. One is that it will be under configuration control, we only have read access, cannot really change the code. The second is we may declare it final class etcetera. The main concept here of the open closed principle is that once the components are successfully developed and tested, we should not change it, but depending on our requirement we might extend it to add additional behavior, to change behavior and so on. The way we implement the open closed principle, that we do not change the existing code, so that no new bugs can be introduced in it. But then we achieve this, that to keep something without change is that we use an abstract or interface class. As you know that an abstract class has some of the methods as abstract. An abstract class can have some data members, but some of the methods are abstract. Whereas, in an interface class we do not have any data members, we only have the method prototypes. But then which one to use, an interface class or abstract class? The answer to that question is that if we have some code and data which are not likely to change and reusable across many other classes, we will use abstract class. but if the methods are not really common to different classes, each one will have their own different methods, then we will have interface class. We will use these abstract classes and interface classes. These are the main principle in the open closed principle. Whenever a new feature is required, we will extend the abstract and interface classes, and the client classes can select the appropriate object through dynamic binding. This principle is also called as program to an interface. As long as we call a method on an interface object or an abstract class object, we will be implementing the open closed principle. We will just try to make sense how this is achieved in our next few minutes discussion. The open closed principle is also called as program to an interface, because the solution to the open closed principle is by using an abstract class or an interface class. The key idea we had said that open is we can add functionality or data by extending it, close we cannot modify. Once the class is working, it does not change, its interface does not change. The other classes which rely on it, they do not have to change, because we are not changing a class which is working, and typically the open closed principle is implemented with abstract classes or interface classes. Now, let us try to understand the role of the interface and abstract classes here. The statement of the open closed principle that once a class is working, it is closed to change. But then to really think of it, that a class needs to change mainly on account of two things. One is that if suddenly we find that there is a problem in the class, we would have to change it, and also we might say that the performance that it was giving at a later point of time, we might find that that is not satisfactory. Let us say it was displaying on a terminal, but then we find that the display is too slow over the years, and we might need to fix it. If you look at the changes that occur to classes, these are the two main reasons. One is that existing bugs and performance problems. And if we need to change it, of course, that is we can always extend it, but then suppose we do not want to just add new features, but these two problems they will not get solved even if we are using extension. One is that the base class itself has problem, later we identified that there is some problem. In that case, we will have to fix it, and also there is problem of the method of the base class, we will have to fix it. But then suppose it is a concrete class, this is always a risk that we will have some errors or there are performance problems, but what about the interface and abstract classes? The interface and abstract classes do not have methods actually, only method prototypes, and therefore, they cannot have bugs latent in them, and also there are no performance issues. So, we can use the interface classes or abstract classes and make them closed to change. If we have this kind of a design, like a client is dependent on a server, maybe it makes a call on the server, makes a method call, then these are dependent. The client is dependent on the server. It violates the open closed principle, because if the server changes, the client need to change. But now, so this is not a good design, it violates the open closed principle, because of the explicit dependency of the client on the server, and the server is a concrete class, and there are likely reasons for it to change, and when it changes, the client will get affected. The bug may propagate, or we change the interface and the client code has to be rewritten. The OCP compliant solution will be that client is dependent on an interface, and that same interface can be implemented by several servers. In this case, the client does not get affected even if the server, certain server has a problem, either a performance issue or a bug. The client code does not have to get recompiled, and bugs cannot propagate to client code, because we are just invoking an interface. The interface itself does not change, and this is the basic principle of OCP, that instead of a client class directly calling a server class, we have the client calling to an interface. This is programmed to an interface, and then there can be several server classes implementing the interface. We can even extend the interface later if we want some interfaces need to be changed or new services are required, we might extend the interface, but this remains, the working code does not get affected, and this is the solution to the open closed problem, is programming to an interface. But one thing must mention here is that this kind of design is required if we anticipate that there can be changes to the server class. But suppose we have a situation where the code is already working for many years, it is a concrete server class and the client is invoking directly the service of the concrete server class, and there is no reason for the server class code to change, there is no bugs, no performance issues can arise. In that case, possibly this design itself may be okay, but in all other situations where the server class can change either due to bugs or performance consideration or new features required, we have to use the OCP solution, where we have the concrete classes, server classes implement the interface, server interface, and the client invokes the methods on the interface. The use of interface classes and abstract classes are the key idea in the open closed principle. We will see that most of the design patterns, they profusely use the interface classes and abstract classes, and one of the reason they do that is to be compliant with OCP. The interface are implemented by many classes, but the interface itself is closed for modification. Interfaces do not have any code there implementing methods and so on. So, there is no chance of a bug, the interface does not have to change, and there are no performance issues as well, because the interface class does not have the method implementations, and therefore, the solution to the open closed principle is to use the interface classes and abstract classes whenever a client class needs to call a server class, and the server class need to change due to various reasons. Now, let us look at an example, a violation of the open closed principle and how we can fix it. Let us say we have this solution where we have this employee roster consists of many employee objects. The employee is a concrete class having employee type etcetera, and some basic methods. Now, we have various types of employees. We have faculty, staff, secretary, engineer etcetera. Now, there are several other classes which invoke services of the employee, because employee is a concrete class and these other classes invoke the specific employee classes, but employee itself is a concrete class. The code of the employee in this case will look like this. Because employee is a concrete class, we have all the employees stored in an array, and depending on the employee type we invoke specific methods on it. And this is not a OCP compliant code, because employee is a concrete class. We can make it OCP compliant. So, there are various reasons why the employee may change. The employee class may change because there are performance issues, or there are bugs in the employee, or there may be new employees added here, and so on. The OCP compliant solution is that the employee roster aggregates employees where employee is a interface, and the different concrete classes implement the employee interface. And here, even though there is a bug in these classes, or there are performance issues, or new employees are added, the employee roster, the classes which are invoking the employee, the methods of the employee do not have to change. So, this is the main idea here, very important principle, the open closed principle. Once we discuss design patterns, if we know this principle, we will understand that why the design patterns have been designed the way they are. With this first principle of open closed principle here, out of the solid principle, 5 principles, we will discuss one principle, we will discuss the other principles in our subsequent sessions. We will stop here and continue in the next session. Thank you.